That didn't help at all. Did you say types or plus? Okay. What else if I always have to this one? Never be next to each other. You're asking us you have to do the couple thing. What? You have to do that long.
Don't we do it like the opposite? Like, isn't it
yeah, you can. What's that called? Complementary.
Yeah.
So like if they are together, then you minus it from the possibility.
Yeah.
It's like, we'll do it.
I think I might actually get
These parties are stressing me out. I'm not going to lie to you. It's like so many weeks I need to lie. And yesterday I was so finished.
Yesterday, I almost
I was
I almost got into negative number.
Okay, let's go over this quickly.
You went into negative.
Then we are done, guys. Okay, it's 12:08. So, this question says, okay. Okay, so first question here. Okay, so you've got cards, and we've got the numbers 1, 2, 3, which are available. Okay, we've got these specific cards, not any number. You can't have 10 digits there, 10 digits there. It's not any number, right? Okay, and then we've got two letters A and B. Okay, they're used by players to create 5-digit cards. Okay, so the example, so what they're saying here is they can go in any position. You don't have to have letters and numbers, right? So basically, what have you got, guys? You've got 5 different things, right? Okay, so 5 different things are available. It's like, how do I arrange 5 of you seated? How many choices for the first stage? For the next one? The next one? Next one? Next one? Okay, and they all have to happen. So that's the fundamental counting principles. Is your number of choices times your number of choices at each stage. 5 times 4 times 3 times 2 times 1. In other words, the number of ways you can arrange 5 things in order is 5 factorial, right? Which is equal to what?
120.
120. Okay, we're happy with that. Okay, right. Then the next one says how many unique 5-digit codes starting with a number can be created, right? So you're going to have, okay, a number, okay, in the first place, okay, right? And then we've got 4 other positions that you can choose, right? 1, 2, 3, 4 other positions we can choose. You agree? Okay. So, how many choices do I have for the number that goes there? Okay, I've got 3 choices for the number, right? Okay, so an example would be this. Okay, would be 1 and then A to B 3, right? And how many choices did you have? If I look at my choices, the number of choices there is 1 times, how many choices for that place? There were 4 times 3 times 2 times 1. You agree with me? Okay? Because you put the fixed number in there, right? Whatever you chose, right? So this is an example of one case. Okay, the number 1. Okay, then you'd have 4 times 3 times 2 times 1. Do you agree with me? Or you could have the number 2, and then 4 choices, 3 choices, 2 choices, 1 choice. You with me? Or you can have the number 3. So in general, for the first place, how many choices do you have? 3 choices for the first thing, right? After that, you're always going to have a choice of 4 times 3 times 2 times 1, which is 4 factorial, right? So you've got 3 lots of 4 factorial. Does that make sense? Okay. So 3 times 4 factorial, which is 72 different choices. We're good with that, guys? Okay, because you could have 1, and then 4 choices, right?
Yes.
Or you could have 2 and 4 choices,
Oh,
right? Or you could have the number 3 and 4 choices. And the number of ways you can arrange the 4 choices is 4 factorial, right? So the number of choices there is 1. So the number of choices you have for that arrangement would be 4 factorial, right? The number of choices you have for that arrangement, you have to put a 2 there. Okay, there's no choice for that, right? Okay, it's not 2 choices, that's the number 2, right? So it's 4 factorial plus 4 factorial plus 4 factorial, which is the same thing, so you could do it like that, but it's the same thing as 3 lots of 4 factorial. Okay. Are we good, guys? Right, last sum ever in a formal lesson. Right. What is the probability that 2 letters will never be next to each other in the code? Well, either, this is what we call a complementary space, remember? Either you're going to have 2 letters next to each other, or not next to each other. Do you agree? There's nothing in between. Either the 2 letters are next to each other, or they're not next to each other, right? Capish? So, it's a probability question. So, what's the probability of the letters next to each other plus the letters not next to each other? What does that have to add up to? Okay, the probability that the letters are next to each other or not next to each other is certain, right? It takes up the whole space. So that's equal to 1, right? To work out the probability that the letters not next to each other directly is really very difficult, right? So we're going to use the logic that the probability that they're not next to each other is equal to what? 1 minus the probability that they are next to each other. Does that make sense? Not next to is always very difficult. Next to, easier. So, let's work out the probability that they're next to each other. Okay. Well, what's the number of ways they can be next to each other? Well, what's the arrangement they're going to be? Well, an example of the arrangement would be, it's just an example, would be the number 1. Okay. Then you'd have A and B next to each other. You agree? Then I could have 2 and 3. Okay. What was the logic we used for the number of arrangements for grouped items? Number of external arrangements, remember that?
Yes.
Okay. The number of ways that grouped items can be arranged equals the number of ways of external arrangements times by the number of ways of internal arrangements of the things that are grouped together. So when we talk about external arrangements, we treat A, B as one thing, right? So the number of ways that those 4 things can be shuffled is what? What's the number of external arrangements? I've got 1, 2, 3, 4 things, right? The number of ways you can arrange 4 things is 4 times 3 times 2 times 1, which is just? Okay, so the number of external arrangements is 4 factorial, right? The number of internal arrangements of the things that are grouped, well, how many things are grouped?
2.
So it's 2 ways or 2 factorial. What do you get for that? 48. Okay? So there are 48 different ways they could be grouped together. Okay? If they said to me, what's the number of ways they're not going to be next to each other? Okay, you could go, well, the total number of arrangements was 5 factorial, right? So you could go 5 factorial minus 48, and that'll give you the number of ways that they could be not next to each other. But we work with probability, so we may as well do this. Okay, so we said we're going to use this logic, nearly done. Okay, that the probability they're not next to each other is 1 minus the probability that they're next to each other. This was the number of ways, what I worked out here is the number of ways that they are next to each other, right? So what's the probability that they're next to each other? What's the key idea for probability? Whenever you see probability, what you're going to say? It's a number of ways the event can take place over the number of elements in the sample space. What's the event? What do we mean by the event? The specific thing we want to happen, which in this case is what? Okay. Sorry, it's going to be equal to that they're next to each other, right? So how many ways could we arrange it so that they're next to each other? What's the number of ways the event can take place? We're working out the probability that they are next to each other, right? Okay, so it's going to be 48. What was the sample space? What are we doing in this question? We're arranging 5 cards, right? So it's going to be 48 over 120 or 5 factorial, they agree?
Yes.
Okay? Or you could have 120 there. So what's the probability that if you take 2 cards out and arrange them in order that the letters are going to be next to each other? Work that out for me. So 48 over 120 or 48 over 5 factorial.
2 over 5.
2 over 5.
Yes.
Okay. So that's the probability they're next to each other. There's 2/5 of a chance that they're going to be next to each other. So finish it off. So what's the probability that they're not next to each other? Yep, we're right. Okay, so the probability they're not next to each other equals 1 minus the probability that they are next to each other, so it's going to be 1 minus 2 over 5, and this is going to be 3 over 5, eh? Or 0.6. Stop sharing. Stop recording.